Hi, my name is Saad Ibrahim with Waterflood Management Group. I am the instructor of the class Waterflood Management. As you know, water flooding is one of the most popular forms of enhanced oil recovery. It has been utilized for a century for a variety of different fields, and it's a proven technology. It has been used widely to improve reserves, recovery. Typically, water flood would give you double the reserves of primary production. So in this course, we start with an introduction about enhanced oil recovery schemes worldwide. Obviously, the focus is on water flooding. We move into the reservoir characterization, how we can characterize reservoir in terms of geology. We talk about reservoir heterogeneity, reservoir feces, and we give a nice case study on how we can include that in our analysis so we come up with the right design for the water flood. We cover rock and fluid properties that relates to water flood, so we talk about how we can obtain representative fluid samples so we know more about the fluid analysis, the bubble point pressure, lots of information about the crude. We talked about relative permeability, capillary pressure, rock wettability, all of these information that can affect the performance of the water flood. The next section will talk about reservoir drives and reserves. Some of the reservoirs, they do have a natural pressure support from an aquifer. They don't need water flooding. So we need to recognize what sort of drive in this reservoir. Some reservoirs don't have much of pressure support, and that's when we definitely need full-fledged water flooding. We cover briefly how we estimate reserves using deterministic and probabilistic techniques. So we know to start with what sort of remaining reserves are available for the water flood. We move into the actual design for the water flood. We start with the basic concepts, what sort of injection requirements are needed for that field in terms of how many barrels per day of water we need to inject. That will affect the surface facility design, the number of injectors. Totally, the capital cost is hinged on how much water we need to handle every day. And then we get into some of the actual detailed design on how which pattern we're going to use for injection, whether we use pattern flooding or peripheral flooding. We talk about some of the technique we use to predict the performance of a water flood, such as the Stiles method, Dijkster and Parson. And also we show some of the numerical tool, and we show a case example on how to use some of the commercial software for predicting the water flood performance. We move into the actual monitoring of the performance of the water flood to ensure that you will achieve the expected recovery factor from the water flood. We show all the tools used by the industry to ensure success monitoring of the water flood, from pressure surveys to looking at the voidage replacement ratio. We talk about the water quality, how we set the standard for water quality to ensure we're not plugging the injectors. We talked about the filtering, the filter size, how we can estimate the size of the filter without spending a significant amount of money. We also have other tools that we use, from the HAL plot to conformance graphs like the water ratio versus cum production. Other tools like also well testing to check if the wells are getting damaged or not. By monitoring the water flood successfully, we can ensure the success of the water flood and the goal of increased reserves is achieved. We also touch base at the end with regard to operating problems during the water flood, from clay problems, the formation of scale, corrosion. All of these problems, we deal with it. We talk about how we can diagnose the problem and how we fix the problem. So that's the outline of the reservoir, the water flood management class. If you have any questions, please contact us and we'll be glad to respond. Thank you again.